We're back for the last session of the day. Hi, Hank.
Hello.
Hope everyone has refilled their refreshments and have enough energy for the last session of the day. Hank, real pleasure to meet again. Hank is a friend of CodeCamp for quite a while now. And we really appreciate that. He's also, I also know him as a community guy. That's a lot of activity that he's doing for the communities. What is community to you, Hank?
Yeah, okay, that is a good question to open with. Hi, so thank you so much for having me back. I would have wished that I could fly to Yash or to some other place, but still happy to be here. So for me, community is a group of like-minded people where we share knowledge, where we help each other out, where we tell stories about what we did with tech, how we can do this, share the news and latest tips, and of course, have some fun besides that.
Yeah, so we're sharing the same passion actually. So now to your session. Machine learning is a hot topic. DevOps is a hot topic as we learned today. I wonder what DevOps and machine learning together will look like.
Yeah,
You've got
so
the
that's
floor.
what I'm going to tell you.
Yeah.
A little bit.
Thank you.
Yes, can I take it away or?
Absolutely, absolutely. Please go ahead. Thank you.
Cool. Thank you, and thanks everyone for sticking around for the last session, DevOps and Machine Learning. So my name is Henk Boelman and I'm a cloud advocate at Microsoft. You can find me on Twitter, on GitHub, and you can read a lot about machine learning in combination with how you can run this in production and how you can do these things as a developer on my blog. So what about this session? I think we have 45 minutes. So first I'm going to talk a little bit about what machine learning actually is, what the capabilities of the Azure cloud are. Then we're going to dive into what the data science process looks like. So we're going to talk a little bit in general about how data science fits into a DevOps team, because that is one thing we need to understand before we can actually start and implement DevOps solutions. So the last part is we're going to see how we can build a machine learning pipeline and put that in a repeatable, like kind of DevOps process, actually using Azure DevOps. So, but first, the big question, what is machine learning anyway? And the easiest, most common definition is, it is giving your computer the ability to learn without explicitly programming your computer. And in practice, that means, I've been a developer for very long, I would write an algorithm. I would run some new data through that algorithm and would say true or false or 10 or 20, it would just give me an answer. But if your problem becomes too big and you can't program that algorithm anymore, you can start training a machine learning model. And with machine learning, this is a little bit changed your approach. So instead of programming the algorithm, you let your computer do that for you by providing it a bunch of answers and a lot of sample data. You run it through a training algorithm and you will get an algorithm, or in other words, called model. And when you have that model, that file, that function that the computer has generated for you, you can run new data through it and you will get a prediction out of it. So machine learning on Azure. So I always like this slide because it shows what kind of levels there all are. So first of all, there are the sophisticated pre-trained models. And these are Microsoft Cognitive Services. These are out-of-the-box machine learning models that are exposed to an API. So from a developer's perspective, it is just calling an API. You can integrate it in any solution. Some of them you can pick up and run them as a Docker container in your own infrastructure. But if that is not sufficient, you need to start creating your own algorithms. So we support all frameworks, and we have a lot of services that can help you with that. So we have Azure Machine Learning, Databricks, Machine Learning Virtual Machines. Of course, we have a lot of CPUs and GPUs. And we can, of course, help you deploy it to an on-prem environment, to a cloud environment, or we can even give them the models, help you deploy models on your edge devices. But today I want to talk about DevOps. So when you are making these models yourself, and we're going to talk about DevOps in combination with AI. So we all know the definition, hopefully at the end of the day, about what DevOps actually is. So DevOps is the union of people, processes, and products to enable continuous delivery of value to your end users. And this clearly illustrates that it is about delivering value to your end users, and the value can be a good working machine learning model. So this explicitly applies also for solutions that have a machine learning component in. And that means we have to add that discipline of data scientists to our DevOps team. And I've been programming for long, and I was getting pretty relaxed with like my DevOps team. We had operations, we had developers, we had front-enders, we had everyone. But now, suddenly, a data scientist or the data scientist teams joined the DevOps team, creating this value for the end user together. So we had to learn what that actually means. What does a data scientist do? So our new team now, the three disciplines we're going to focus on in these presentations are developers, data scientists, and operations. So I had to level a little bit up and start to understand what a data scientist does, how the workflow works. I knew that for developers, I knew that for operations, but not for data scientists. So it is quite important to understand this data science process. So I learned that every data science process starts with asking a sharp question, because machine learning models can answer questions for you, like a function. For that, you need to collect data. And one thing I learned also is that you never have enough data. So start collecting it, collect it. Then we all know data is messy and it is never in the right format. So before we can do that, we need to prepare this data. We need to shape it so it can run through our algorithm. We select a training algorithm, we train the model, and then we can finally start using that function or use the answer in our solutions. So what are we going to pick out this box today for our demo? So we're going to use Azure Machine Learning. We're going to create a PyTorch model, run that on a GPU cluster, and deploy it in the cloud. And we're going to all automate that whole process. And the question we're going to answer, one of my favorite questions and my favorite data sets, is it Marge, is it Homer, or any other Simpson? And for that, we're going to use my Lego data set. So let's take a look at how these tools and how these things all connect together. So let's say we have a data scientist. It's going to use his or her favorite tools. We'll use some kind of version control for the scripts, for the training algorithms, use Azure Machine Learning, controlled by Azure DevOps, and it's going to deliver a model in a service called Model Management, which is part of Azure Machine Learning. And you can see this model management is like kind of a NuGet package repository. So a data science can check in a model, and a developer can check out that model and use it in the software he or she is writing. And because a developer mostly will use different tools than a data scientist. We'll use a different version control system, different build pipelines. And in our case, we're going to deliver a container wrapped with an API wrapped around the model. And then here you already see that now the AI service is just a container registered in Azure Container Registry. So operations can pick out that container and just deploy it like it would deploy any other container. And then our client can just start sending photos to that API running in this Azure Kubernetes service. So the first thing what we're going to do, I almost forgot, is we are going to commit some code to kick off my pipeline. We call this code camp. We go to Git. We have a change here. We commit that. Code camp committed. And let's hope we can actually push this to our repository. So we will come back later. Yes, it seems like it is committed. So let's hope that actually worked. So we can see that back later what it does, because it takes around 15 to 20 minutes to run. So let's zoom into what Azure Machine Learning Studio or Service or Azure Machine Learning actually is. It is a fully managed cloud service that enables us to easily work together as a team. So what is it? It is a set of cloud services. So it is not just one thing. It is an Azure Container Registry, it is blob storage, it's a key vault, it's clusters, it's virtual machines. But we can control that set of services through a Python SDK or through the Azure CLI or through the portal. And it helps us to do all those tasks you saw in the previous slide. It can help us prepare data, build model, manage our model, and even deploy the model so we can use the answer. So to get started with that, we need to go to 3 phases. We need to prepare, experiment, and deploy. So first we set up the environment so we can work together. Then we can actually train our model so we have something to deploy, and then we can actually start talking about deploying it. So step 1 is preparing our environment. We can do that in multiple ways. We can do that in the Azure portal, VS Code, Azure Notebooks, Azure CLI, just a few comments. I'm going to show you code, Python code using the Python SDK, because that explains the best how it works. So here we say create a new workspace, point a subscription and a resource group, and pick a location. So one important thing to know, later we're going to create compute clusters. If you pick a region, first check which type of compute are available in that region. Because if you want to train on a GPU cluster, you want to have those GPU-enabled virtual machines available in that region. You can write out a config, check in that configuration file, and everyone else can check out that configuration file and connect to the same workspace. And the workspace looks like this. It lives outside of the Azure portal on ml.azure.com. And you can see many things there. So let's zoom into a little bit of the menu items and see what is possible. So first we have data sets. Here we can manage our data. We have experiment. Here we can see all our training runs. We have models. This is the model management part I was talking about. If you have a model, you can register your model there and pick it out. Then there are endpoints. So the real-time endpoints, this is where your deployed models live. And we have pipeline endpoints. And these are the endpoints. We will dive in a little bit later, but you can create pipelines to train your models. And when you publish a pipeline, it becomes an endpoint. So you can call that endpoint and it will kick off that training workflow for you. There is compute. Under compute, you can manage your different types of compute. And there are data stores. Data stores manage the connections to the data. So we need compute, obviously. With these two lines, I'm creating a standard NC6 cluster. And this is a GPU-enabled cluster with always one node up and running. So this is always billing my credit card. You can put it to 0, so it automatically shuts down when there is nothing to do. And it can spin up to a maximum of 6 nodes. And then I just say, create it. I wait 10 minutes and it is there. The third thing I need is storage, because I need a place where my data can be stored. In this case, our Simset dataset. So I can have my default data store, that comes out of the box with Azure Machine Learning, or I can register any Azure Blob container as a data store, even outside of my subscription. So this is your environment. You create a workspace, you create compute, create storage, and these resources you share as a team. So now the interesting part comes, and we can start creating a machine learning pipeline to deliver our model. And for that, I use the word pipelines, and we've already seen today talking about Azure Pipelines. We have GitHub Actions and so on. So let me explain the difference a little bit. So we have Azure Machine Learning Pipelines and Azure Pipelines, and they're both two completely separate things, but they really work well together. So Azure Machine Learning Pipelines are very good in training your model, and Azure Pipelines are good in orchestrating things. So Azure Machine Learning Service Pipelines are workflows of steps that can use data sources, data sets, and run on compute targets. So they're good for unintended runs, meaning that we can just kick them off in the night and they will run, and we can log into the portal or connect through the with the Python SDK to see what they're doing in the morning. So they're reusable. We can edit them because they're versioned, and we can track and see how our models evolve over time. Azure Pipelines, on the other hand, are good for orchestrating and for continuous integration and continuous delivery. So we can set up gates and tasks for quality. We can integrate with other services, and they can trigger on code changes. So they can, for instance, build new pipelines for us. Or if there is a new model registered in model management, we can kick off an Azure pipeline that will deploy our model to a test environment, run some unit tests, and all the good stuff we saw today. So the smallest thing we have is a pipeline step. A pipeline consists of multiple of these pipeline steps. So what is a pipeline step? A pipeline step runs a script on a compute target in a Docker container. And it's mostly Python. It can have input, like a data set. It can have parameters, like all the hyperparameters, number of training rounds, and so on. And it generates output, which it can pass on to the next step, to the next step, to the next step, to the next step. So this is how our pipeline is going to look. We have a blob storage, and on that blob storage, we have a set of Simpson images, a data set. But the data set is not in the right format. So we have to prepare our data set. We have to put it in nice folders, shape the data so the input size of the images are all the same. And that first step will deliver us a processed data set. Time for the children to come home if you manage to hear them. Okay, they're happy to be home. So we have a process data set. So that process data set is picked up by the train the model PyTorch, by the train the model with a PyTorch estimator step, and this will actually train our model and deliver as a model. We give that model to the latest data set, and then we deliver a model in model management. So this is how a training file will look like. This is how a training file will look like. So here we see a lot of training the layers. So this can be any file your data scientist will make, and that can run in a container. There are a few specifications, but I will dive into that a little bit later. So we need to have that training file. And the training file runs in an estimator. And basically the estimator is the configuration for the Docker container where this training script is going to run in. So we tell it where it can find the scripts. It can have parameters. We tell it on which cluster it has to run, which script it has to execute, if it has to use a GPU, and we can tell which additional Python packages need to be installed. and we can tell it which framework of PyTorch it has to use. But if you want to use TensorFlow, you can just replace the word PyTorch with TensorFlow, and you get a base image where a TensorFlow script will run in. And when we have that estimator, we have to wrap that estimator in an estimator step, pointing where it can find our training data and where it has to deliver the output. So we create a pipeline. We say, hey, this is the pre-process step, this is the train step, this is the register step. We say pipeline is new pipeline. These are your steps. We publish the pipeline, then we get this API, which we can call, and then we can submit it. And this is how it looks in the portal. We submit it to the experiment. It will start running all the individual steps, and we can zoom into these steps. So let's see how this looks in a demo, because enough talking, so let's see it. So what we're going to do, we're first going to create this, this pipeline from an Azure notebook so we can actually see what is going on. So we first start with importing a lot of dependencies, but you see it is all from the Azure ML package. And we connect to our workspace, to our created compute target, to our default data store, and then to our experiment. I have already uploaded my data set to this data store, to the Simpsons version, Lego version 3. And that is the input that my pipeline is going to take. So that is what I'm specifying here. Take this Lego data Simpsons data set as input. Tell where it can find my training scripts. Tell what the name of the model is it has to deliver. And tell it to log this run under which experiment. So first we're going to create a data preparation step, and that is basically run this prep.py file. I have that also here, just a file, and the only thing this thing is going to do is copy some files from one path to another path. So we create that step. And this is the trainable step. This is like the most difficult step there is. So here we specify the output where it is going to deliver our model. We have some additional parameters. We have here the PyTorch estimator with the training script. So we can zoom into the training script quickly. This training script I just got from the PyTorch website when I searched for transfer learning. I only added a reference, made sure I could parse arguments, and added some additional logging, and made sure I write out the output in the correct folder, in the outputs folder, because then it is copied over back to our experiment. And then the last step, register the model. So now we have our 3 steps, and we can register that step, register that pipeline created, and we validate it, and now we can publish it. So now we could run it, but here you see it takes 9 minutes. So this one I just kicked off like 4 hours ago, and it's completed. So here we can see all the different steps running. So we can click on those steps here on the train estimator. We see how our model evolved. And here we see that it should have delivered our model to model management. So this is what I want to show you here. So let's dive into this interface a little bit. We already showed it a little bit how this looked. But first, this is our data set, the Lego data set stored here. Here are our experiments. Here is our pipeline created from Azure DevOps, which we're going to zoom in a little bit later. That is why we did the commit in the beginning. And this is the experiment from our notebook where we just looked into. See, our latest run was today, took 9 minutes. You can click on that. And here we also find back the overview of our pipeline. You can zoom into the individual steps. Here we have the output of the pipeline. Actually, our model is in here with our labels, just a text file. We then save metrics here, and here we have some other new features in preview that it talks about explainability and if our model is fair enough for all the Simpsons. And the cool thing is now that our pipeline endpoints are published. So I think this is the one we've just created. And now we can just go to this interface and say, run this pipeline, run this pipeline. You can change the input data here. You can just change where it gets the data set from. Then it will run. And this is also available as an API under endpoints. Somewhere. Here. Yeah. So we can just call this with the right credentials and it will kick off this pipeline for us. So that is a pipeline. So this Azure ML pipeline, which does the data processing, training the model, and it finally delivers us a model in model management. So I'm trying to make it a little bit more clear what happens when you kick off one of those pipelines. So that can be done for the Jupyter Notebook, from Azure DevOps, from anything that can call a REST API. At the moment you do that, it snapshots your folder with your training scripts. It starts spinning up your run, your experiment. In this case, it has all the different steps. And it is creating for every step a separate Docker container, which it's going to deploy to our compute target. It will mount all our data stores, and then it launches all the training scripts, like the prep script, the train script. And then it starts generating output back to the experiment and back to if you have connected your Jupyter Notebook to look at it. And then when it is done, it copies over all the output. So everything is versioned under your experiment. So we're not going to test the model yet. We're going to do that at the last step. So we now have an Azure Machine Learning Service pipeline. And we've seen how we can create that from a Jupyter Notebook. And the thing I want you to remember from Azure Machine Learning Service Pipelines is that it is to create a repeatable process to deliver a machine learning model. You now just saw me doing that from a Jupyter Notebook, but there are other ways because I'm telling about DevOps for AI, and you've seen me doing everything from a Jupyter Notebook running locally on my computer. So there must be a better way. And we have to set up continuous integration for this. We need to set up, first of all, source control. So the main benefit of having this in source control is that we have code and comments only. We can have every part of the pipeline version. You already saw a sneak peek that I have those training scripts in VS Code. So everything I change in one of those scripts, I can commit to my GitHub repository and say, hey, change this part of the model, change this part of the model. And that is exactly what source control is for. So that perfectly works with also data science. We can add a little bit more. We can add also our infrastructure and dependencies in source control, and maybe a small test set so everyone can quickly check if this model is doing well. So everything should be in source control except your large training data, because nobody wanted to have like 10 gigabytes of Simpson pictures in a GitHub repository. So then we have to talk about continuous integration. We want to trigger on code changes. If someone changes something in the configuration of the model, then I want to at least train something to see if it works. So it can refresh and execute our Azure Machine Learning pipeline. And then before we do that, we can do some code quality on the code they have just committed. We can do some unit testing. We can do some linting, code quality checks before we actually let it create this new Azure Machine Learning Service pipeline. We can work with pull requests. So let's see how we can set up an Azure pipeline for Azure Machine Learning. So we had our Jupyter notebook where we defined all the steps. So what I've done is I just created a setup pipeline Python file where we just specify how to create this pipeline. And this is exactly the same code as that you saw in the Jupyter notebook, but now we don't have it in a Jupyter notebook and it is code only, which will make it easier to commit. And this one is referencing to all these separate training scripts in steps. So here we have our prep script, our register script, our train script, and this is actually where we changed something. And there are two problems in this file. So that's it. And then I have an Azure pipeline built here. And that basically doesn't do that much. So it triggers on everything that is on the master. It's using an Ubuntu build agent. It sets my Python version to 3.6. And then it installs the Azure ML SDK CLI client. Then I have a service principal that has access to my subscription. And then I just run setup pipeline.py. And because I also have my configuration installed, my config file here, which points to the right Azure Machine Learning Service workspace, the Azure CLI is able to connect with the service principal to this workspace for me from Azure DevOps. So now let's have a look in Azure DevOps and see, oh, go away. Can this move? Go away, go, yeah. Good. So let's go to Azure, yeah, it goes then there. Yeah, perfect. So here is our pipeline. We see that it's figured out our commit with CodeCamp. It ran 22 minutes ago for 1 minute. And here we see that it did exactly what was in our Azure pipeline. It checked out the repository, it set the Python version, it installed the SDK on it, and it ran our pipeline. Let me see where it is. CLI. Oh yeah, here it is. It is falling back on our CLI credentials. It is running an unintended mode. And here we see that it has selected my workspace, the compute target, the blob. It's creating our 3 steps. It is referencing us to our workstop blob, and it submitted the pipeline. And it actually gave us a link we can click on. And here we see now our pipeline, and it has already run this pipeline. So let's see if it also delivered something. Yes, and it also delivered us a model. So now you see you can use your own Jupyter notebook to experiment a little bit. Are these pipeline steps right, wrong? Then you migrate them to a Python file, and then you can run it using Azure DevOps on every code commit and every code change. So now, wait, that is one step I should not forget to show you. So this pipeline should have delivered as a model with the tag CodeCamp. And it actually did. This is what we changed the tag for this model. So here it is. We see which pipeline has generated this model. We see that it is already deployed. We will dive in that later. And here are our model artifacts. So now let's see how we can pick up that model from model management, write some software around it, and deploy it into production. So we can use Azure Machine Learning Service to do this for us. For that, we need a model, a file that will load in the model and does the scoring against the model. And then we need a file that specifies the environment. We wrap those three things up and we end up with a Docker image. And that Docker image we can deploy to an Azure container instance, to an Azure Kubernetes service, but it is registered in our Azure container registry. So we can just pick it out and do whatever we want with it. But this is done with a command line. So there must be a better way of doing this. And I think there is. So we now have clearly looked at our development of our data scientist process, how to deliver that model in a repeatable way. So now we have to take a look at this developer. And the developer has to write software around it, use their own build pipelines and deliver this Azure container. And to do that, he or she can write a simple app. And that app is constructed from a file, something that loads in the model and exposes an HTTP server. It can specify a Docker container, requirements, which other Python packages have to be installed. We have an Azure Machine Learning config. That's the file that specifies where it can pick the model. So basically you specify where the NuGet repository is. And then we have a file that will actually retrieve the latest version of that model for us. And this is how a build pipeline then would look if you write your own custom solution around it. So the last thing I want to show you is how you can use Azure DevOps to deploy this model. We go back to our Azure DevOps. So what we can do under releases is there is a specific trigger for a release if there is a new model in model management. So here we see our model, release 9. And we can, sorry, I'm going to go here, edit. Click here. So the only thing what we have to do here is, so when the model comes in here on the pipelines, here we have our model artifact. It is in my Azure Machine Learning Service Cybertron service endpoint. For this model name, for the latest version, it's going to trigger this deployment. So here we download the model, and then we can say with this Azure ML model deploy step, deploy this model to this endpoint from this workspace, this model artifact, using this inference config, and to deploy it to this container instance. And that it actually did, because here we can see it, 620, my 620. It's here that the release. Let's see, oh no, let's see in the logs. Here it started deploying it with my inference config and deployment config. And these configurations files are actually also in GitHub, where we have specified how it should run, how the Azure container instance should look like. And this is the inference config, which specifies which scoring file it has to load, which environment file it has to load. Here's the environment file that will specify what needs to be installed in that Docker container. And this is the scoring file. Then this file is actually responsible for loading in the model. So what we can do now is if we use this, we can see under the model where it is deployed in which endpoint. So here we have our REST endpoint, which we can use, and it says it needs a variable image. And what we can do is we can quickly find us a Simpson image because we still have some minutes left. If I can click here on the plus. Simpsons. Lego, sorry. Because we all want to see it working. Here we have a test set with, let's do Homer, say download. So we can give this one an image. And here it says that it is Homer Simpson, and it is 93% sure that is Homer. You can replace it with Bart. It also works with Bart and with Marge. And then Marge is probably with a lower. Yes. And it is also doing Marge. And this is the model that is created by that first commit I did when we started this presentation. So let's have a recap about the steps I was trying to explain to you. So we have a data scientist that works in his or her own specific way, but a tool like Azure Machine Learning Service really helps you structurize that process while giving the flexibility that you can run your own scripts. We can use tools like Azure DevOps to automate this by creating the pipelines for us, add some code quality checks, engage pull requests on it, but eventually it will deliver us a model in model management, which anyone can pick out with the appropriate access. Then a developer can write software around it, using Visual Studio Code, any tool, because it is just a function you download from that model management and integrate. And you probably want to build that software in your own way with another build pipeline and deliver maybe this in an Azure Container Registry. And then operations can pick up the solution and deploy it like it would deploy any other software. So we have our client that can then call our API. So this is what I wanted to show you today. I hope it was clear. If not, all this code is available on my GitHub, github/Henky, or on my blog, or if you have any questions, you can ask me on Twitter.
We will definitely do so, Henk. Thank you very, very much. Looks like the process is pretty streamlined, I would say. That's the main strength that I'm seeing here. From your experience, are you aware of any, I don't know, drawbacks or known problems that will be, of course, very soon solved and so on? I mean, anything that you could advise us if we're just starting with the tool set?
Yeah. When you of course work in a team, I've done this before. Before I joined Microsoft, I was working in a team where we had to deploy one of these solutions. Is that I found it very useful that you understand from each other what you are doing and that you're building this process together. So it is not only the data scientists that understand what is going on, but you can do this as a team. And of course, more people know more than one person. Because what can happen, of course, is that someone does it and then leaves the team and then nobody understands it again.
Okay. Thank you. Are you aware of any, I don't know, new cool things that Microsoft is preparing in this space? Anything that you could share with us?
There are a lot of cool things. So recently, the fairness and explainability was announced. So, and we just saw that it is integrated in preview now in Azure Machine Learning service. So I think one of the cool things is with this product is that new features and new things are added all the time. So, and now we are looking at how can you explain them all? Is it fair? Is it not discriminating Homer against Bart or such kind of things? But any new things, I don't know.
Okay.
But let's wait, and maybe something on Ignite. We never know.
Yeah, exactly. Well, then let's wait for that. So Henk, thank you so much for being yet again with us. Of course, we're looking for the next event, and you're more than welcome. Hope time will allow you.
Yep.
I'm also, of course, looking forward to your next trip to Iași or Bucharest or Cluj or whatever.
Exactly. I'm looking forward to that too. Yeah.
Yeah, not sure if you're able to see my background here, but here's the community.
Perfect. Yeah, I can see it very small.
Some of these people actually attended some of these sessions in person.
Oh, that's good. That's nice.
Yeah, exactly. Let's keep that memory in mind, and hopefully it's gonna well be possible soon, pretty soon, to meet again.